Okay, guys, any questions or concerns that you would like to be addressed in the FPGA related to FPGAs or custom accelerators? Let me know.
Like I have, there was one news some back I read like about Intel trying to fit FPGA within their computer. So within the computer. So how uh, feasible do you think that is? Just a general question.
So I think they are already doing it in different places. So the way it is, I don't know the exact details, but what is commonly used is a CPU coupled with an FPGA. Okay, so it's like you have a CPU and to the CPU and the FPGA either share the same memory or they have an offload like an accelerator kind of coupling via PCI or something to the FPGA board. That has been there all the time. Okay, so just like how you have your GPU card, an FPGA card is being used in many places. In addition, what they are saying is they'll put an FPGA and a CPU, like a high end, some I don't know 24 core or something, together on the same die, and also put some memory along with it, right? So that is something I don't know the exact details, but the point is, if it is together on the same chip, then communication becomes cheaper, memory accesses become cheaper, etc. Right? So it depends on how you want to couple the FPGA. Is it you have a sequence of code running and one you want to make a function or you want to have some function which is run entirely in the FPGA, then you just call that function which is actually running on the FPGA. Or if you want to have it very closely coupled, then you have, let's say, a few instructions that are run on the FPGA, then it has to be much closely coupled to the processor's microarchitecture as custom instructions. Yeah, it depends on how often you want to call the custom accelerator. Does that make sense?
So it might be something like they might give um, pre-made bit files or something, and that will be like put on the FPGA every time that particular function is like being used in the FPGA, something like that maybe.
Um, so is the FPGA being is made available for user programs or no?
Yeah. So if the but like it may take, like as you told in the lectures, ma'am, like it will take a lot of time to really like make our own um, uh, codes for the FPGA. So maybe like for quick usage, there might be like some existing
Yeah.
bit files which
Uh-huh.
can be used.
Okay, I got what you're asking. So how can we quickly start using an FPGA which is coupled to the CPU? I think that is your question, right? So,
Yes.
yeah, most of the vendors now, Intel and others, are making many libraries available. So, for example, if you want to do some uh, like you have math.h, now there is something called math.h in high level synthesis also, where you can include the library and call functions. Okay, so you don't have to actually write your own code for all these basic math functions, and these have been written and implemented on FPGA, so you can just include those additional libraries and write your own C code that calls these functions. So like that, many libraries are being provided. There is math is one example. Graph libraries are made available. I think there are a bunch of image processing libraries made available. Even deep learning, they have made available some kind of IPs which have been pre-implemented. So all you have to do is change some of the parameters and you have it up and running on your FPGA. Right? So a lot of support is being made available so that you can quickly program FPGAs actually. Many of it you don't have to do it from scratch anymore.
Yes, ma'am. And why is the a process like from HDL to bit file at taking so long? Like I am not very familiar
Yeah.
with that, but
Mhm.
yeah.
So the process of converting HDL to bitstream involves many stages simply because you start with defining the functionality, and the language is only just a media to describe the functionality. Finally, it has to be realizable physically, right? It has to be translated into logic gates, and these logic gates have to be mapped onto what is available in the FPGA fabric, which is like LUTs and DSP slices, etc. So it has to go through these transformations, right? From language to gate level representation to technology specific representation, and then you have to pack these LUTs, etc., in CLBs, and then you have to place these CLBs in certain locations so that your timing requirements are met. Then you have to physically connect them, right? So you have to uh, select the correct routing path, and the routing resource. So all of these are compute intensive algorithms, right? So that's why it takes long. Does that make sense?
Yes, ma'am. So will usage of IPs or something from a library, like will that speeden up the
Say that
process?
again. Say that again.
Like is it feasible like to have like, suppose let's say there's already um let's say like some combination circuit is already present as a bit file in the library, and is it feasible to just use that same bit file and then rest of the parts alone the compiler needs to generate? Is that feasible? Like,
So bit file is the final output, right? The final file format for configuring your device. Uh, that's your entire design. So libraries that
yes,
are
yes.
made available are still um, in the high level representation. Okay, they can also be in the form of macros and IPs, which have been, have gone through the process, and you can simply put together a bunch of these macros and just, finally just do a little bit of stitching up in terms of routing. That will reduce a lot of design time. Yeah, that is also done. Yeah, like
Yes, ma'am.
you have some fixed macros that are already available, and you can use them.
Okay, yes, ma'am.
All right. Any other questions?
Ma'am, can you explain ROM on FPGA means how that is loaded? Means how operating system is loaded there a little bit.
A ROM or operating system?
Means operating system on FPGA. You were saying na, in morning that two operating system running side by side. So how it is happening? Means even
It is nothing different from the way it is in normal processors, since you already have a processor sitting on the same chip. It will be just the way it is done in your traditional processing environments. It is nothing different. So whatever processor you have, let's say you have whatever your Xeon or whatever, instead of Xeon, what is available on the FPGA fabric is an ARM 7 or something. Some I don't remember the exact version, but pretty much the same technology and of any other hard processor that is available in the market. So they have taken that, implemented it just beside the FPGA fabric. So it behaves just the way any other processor would behave. Is that okay? That's a hard processor. Now, if you have a soft processor,
Even
what I mean by soft processor is you have the description of the processor, let's say HDL files and stuff. So you map that processor onto the configurable logic block. So it behaves exactly like, functionally exactly like a processor sitting anywhere else. So since it is able to compile any OS onto it, it can run any OS.
okay, ma'am.
Yeah, it's complete in terms of compiler toolchain and all that. It is just, it's complete. It has all kinds of ISA support, so it can compile any code that is written, just like any other processor if it is implemented as a standalone processor.
Means if I compare, is it same like we are running two operating system like Windows and Ubuntu on the same machine? Is it like same now? Means there also in terms of FPGAs, or
So
is
I
it?
don't know if Windows we are able to run, but I know there are different versions of Linux that can be compiled onto RISC-V and ARM processors. Um, yeah, it can be a scaled down version like an embedded OS.
Yeah, yeah.
Yeah, it because of the support of the ISA, right? So it is limited in. The question is, what do you want to do with the OS, right?
No, 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 no. I was saying like just like I use two operating systems simultaneously here. So not simultaneously, but one at a time. So there in
Mhm.
FPGA also, it will not be like you were saying like two operating system running simultaneously without any giving any difficulty to others. So that's why I asked that. Means how it
So
can be
two
possible.
operating systems, I haven't done it myself, but I would imagine if you have two instances of processors running on an FPGA, then they can run OSs independently. You get what
Okay,
I'm
okay.
saying, right? So
Yeah,
these
it is
FPGAs
for
are very,
two different process.
yeah, yeah.
Ah,
So they are quite huge. You can put a few processors on a single FPGA. So in that context, I would imagine putting two different versions of the OS should be doable.
yeah, okay, ma'am. Yeah, understood now.
Okay. Yeah, but an OS is a kill. It's an overkill, no? On an FPGA, we wouldn't want to do that unless you're managing some lot of applications that are in software versus hardware and stuff. Unless you need such a exhaustive manager, you wouldn't want to run an OS. I think bare metal is much easier to manage.
Yes, ma'am.
All right, so I hope you guys are motivated to try and experiment with one of the tools um, that is available open source, and maybe you will experiment with some application, make a comparison with CPUs. Now that you also did GPUs, you can do that as well and kind of understand which one is better than the other and stuff. If I'm not wrong, even TPU is accessible through Google Cloud. You can
Yeah.
Same with this
access.
as well.
We can access TPU also.
Yeah. So I would strongly encourage you to take any C code anywhere. Just download one C code that is fairly decent in terms of computation. Run it on your CPU. Run the same code on the TPU. Run the same code on GPU. Run it on the FPGA environment. You don't even need the dev cloud, etc. If you sign up, you can actually run it on the device and see how performance changes. Does it change with problem size, etc.
What tool should we use for TPU?
I think it's called Cloud TPU. It's just like this Google collab.
Like Google Colab has TPU, so
I have not tried it myself, but I think it's called Cloud TPU. You can Google because TPU is from
oh,
Google, right? So they want people to use.
oh, okay, so it could. So what language do they use? Just normal C code or not sure?
I am not sure at all. Sorry, but I know TensorFlow runs directly on cloud on TPU.
Yes, ma'am.
TensorFlow means Python.
Yeah, Python. Yeah, Python. Mhm. Yeah, so that's an interesting study. I mean, if you try that much, I think you are already doing well in terms of understanding the architecture, doing some performance comparison. It can end up being some good, lead to good and interesting um, problem solving. Okay, any other concerns?
No, ma'am.
All right, so if there are any other questions, please feel free to send me an email. I'll be happy to answer them. Otherwise, should we wrap up for the day and meet tomorrow in the morning?
Like some slides are of previous week is not uploaded. Like
Yeah, I have
so,
whatever was on the chat, I have requested the speakers. I have uploaded some one or two just now. As and how I get it, I will upload it.
yes, ma'am.
I think just one lecture is missing. I'll upload it later when I get it. Okay, so if there's nothing else, thank you, and I'll see you tomorrow in the morning.
Thank you,
Thank you.
ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.